In this video, we will compute the surface integral of a scalar function over a surface which is given as a graph. So here, our surface is given as the paraboloid z equals 1 minus x squared minus y squared, and just the part above the xy plane. So, this type of thing. And so, to compute the surface integral of a scalar function, we have to do a couple things. We have to substitute everywhere we see z in the function. We have to substitute the function whose graph gives us our surface. So in this example, we have to substitute for z 1 minus x squared minus y squared in the integrand. So this becomes square root of, and if you plug in for z 1 minus x squared minus y squared and distribute, multiply everything out, you'll get underneath the square root 1 plus 4 x squared plus y squared. And then we have to remember what the ds is. Remember, in general, for a graph, ds is this quantity, square root of 1 plus fx squared plus fy squared dx dy. In this case, our f is 1 minus x squared minus y squared, so fx is minus 2x and fy is minus 2y. Therefore, our ds comes out to be 1 plus 4x squared plus 4y squared. And coincidentally, these two square root expressions are exactly the same. So when we multiply them together, we just get rid of the square root. Oh, and forgot one thing. We need to put the bounds on the integral. When we substitute everything like this, the new domain for the integral becomes d, which is the region in the xy plane that the graph sits above. In other words, the shadow of the graph on the ground, on the plane z equals 0. So here in this case, it's this disk of radius 1, where the graph meets the xy plane. So here in my picture, that's d, it's the unit disk. So to simplify things, the square root goes away. And at this point, it's probably a good idea to change to polar coordinates to finish the integral. So d is the unit disk, so we have r going from 0 to 1, theta going from 0 to 2 pi. X is r cosine theta, and it's squared. X squared plus y squared is just r squared, and dA becomes r dr d theta. So if we simplify, sort of multiply things together, we get r cubed plus 4r to the 5th times cosine squared theta. So just sort of pulling out the cosine squared and multiplying the r's through the parentheses. Okay, now let's do the first integral in the variable r. So Integral of r cubed gives us r to the 4th over 4. From 0 to 1, that's 1/4. And the integral of 4r to the 5th is 4 over 6 r to the 6th. From 0 to 1, that's 4 over 6, which is the same as 2/3. And if we add these fractions together, we get 11 over 12. Now to integrate cosine squared, we use the trig identity. Cosine squared is equal to 1/2, so we'll multiply the 1/2 outside. 1/2, 1 plus cosine of 2 theta. Integral of 1 from 0 to 2 pi is just 2 pi. Integral of cosine 2 theta is 1/2 sine of 2 theta. And we have to go from 0 to 2 pi. But when we plug in 0 and 2 pi, we get 0 both times, so this is just 0 minus 0. So in the end, our final answer is just 11 over 12 pi.